Okay, so let's look at this first problem. Now, I'm going to show you a model in these problems, just the way that I have found to better understand how to work the problem. So, and also I said, go ahead and have your copy of this. If you don't have you don't have to print it. Just make sure you can put down the given. You can actually put it on just a regular sheet of paper, but I encourage you to have a paper and pencil and pen out because I'm going to ask you for these answers. So during the first 22 minutes of a 1 hour trip, so that tells us that time one is 22 minutes. And the total time, we call that T total. The total time is going to be 1 hour, or we can just say 60 minutes because we know the conversions between an hour and minutes. So since it's in minutes here, we can put minutes also here. Has an average speed. So this average speed is for the first part of the trip, which is 14 meters per second. What must be the average of the car during the last 38 minutes? So that means for time two, which is 38 minutes, I need to find out what is the average speed. What's the average speed of the car for the last 38 minutes? Now, in order to do this, they gave me the most useful information was the average. It says if the car should have an average speed overall, which means my total average is 25 meters per second for the entire trip. So that means then, if you listen very carefully, what this means is this. If I can find the speed for the second half of the trip, then that average speed would be the speed for the entire trip. Now, some of you may be thinking, oh, let me just add these two times together, but that will only give me the total time. I know what that is. Or you may say, well, what's the average? What number plus four? Go ahead. Does someone have a question? Okay. So what you really want to do in order to understand the question and to answer it properly, understand what average speed means. So average speed, the speed here is the total distance over the time. So if I know speed one, I can find distance one and time one. Similarly, if I know, or I can find speed two, I can find speed two if I know distance two, and time two. So that means that the first thing I got to find is distance two, because in order for me to find the speed, I need to know the distance. So what do? Well, first thing I can do then is I can find total distance, because we know that the total distance, the total time, is the total distance divided by the total time. Okay, well, now you say, well, what does that mean? Well, we know that we have the total speed, we have the total time, we can find the total distance. Now, the total distance, we can subtract distance one, which we can find also because we know V1 and T1. And from that information, we can find the distance two, which is total distance minus D1. So now I want you to, at your desk, first give me the total distance. Okay, I want you to go into chat and find for me first the total distance. And of course, it's in SI units of meters. So that means then That means then that it will require converting these minutes. But you already know that every minute has 60 seconds. So you simply multiply 22 minutes by 60 because you already know that conversion in your head. So that means then that you can find, first you can find D1 because you know V1 and you know T1. Okay. Then you're going to find D total, because you know V total and you know T total. And from there, you're going to find D2. So you can work on any part of that. Just when you give your answers in chat, just say D1, I know what that one stands for, DT, I know what that stands for, D2. And then finally, you're going to find V2, because V2 is going to be D2 divided by what? T2. Okay, so I'm going to go to chat. I have my paper ready to give some extra credit for those who are working these problems out. You're looking for D1, D total, D2, and then finally V2. Okay, so someone said D1 is 18480. That was Alexi. Okay. Okay, Keston says that D2, he's already jumped to D2. Okay, Keston has jumped to D2, but we never did get D total. So let me see what D total is, which is good to get D2, which means you must have found D total also. So Keston can also give us D total since he already has D2. Okay, so I see D1, I see D2, I see D total. Okay, very good. All right. So now that I know D2 and I also know T2, who can give me the answer for V2? Okay. So if you say 31.3368, that would mean then that I'm going to choose answer what? D. Okay, very good. Kaylin, okay, very good. Very good. 31.4, very good. Okay, any questions on this problem? You can come off mute if you have a question. I'll be happy to assist you. No questions? Okay, great. Now, let's move to number 2. Okay. Number 2. Again, we want to identify what is given in the problem. A pitcher delivers a fastball with velocity 55 meters per second to the south. So that means that the initial speed is 55 meters per second, and it's negative because it's to the south, and it's velocity, it's a vector. The batter hits the ball and gives it a velocity of 45 meters to the north. So my final speed is positive 45, and that's because north is up, and that's positive. What was the average acceleration for the 2 milliseconds? So my time now is 2 milliseconds. So my time is 2 times 10 to the minus 3 seconds. So we define acceleration as the change in velocity over time. When you're driving down the road, you accelerate by changing your speed or changing your velocity over a period of time. So now I need to know what is change in velocity. And we define that as V final minus V initial. That's how we define change. So we know V final, we know V initial, we know time. So please go to your calculator and calculate the acceleration. Okay, let's see who can give me that answer. Okay, Nigel. Kaylin, okay, Kaylin was first, very good. 50,000, very good. Now, does anybody have difficulty? Oh, I'm sorry, one other thing. That 50,000, you see we have answers B and D. So the magnitude is 50,000. Okay, very good. Nigel is saying it's south. He's saying it's south because when you saw that answer, your answer was negative. And negative, of course, indicates what? To the south. So very good. Any questions before I go on? So I hope you see now that solving these problems is just a matter of you writing down the correct equation with the correct units and the correct sign. And then you're able to plug it in and solve the problem. Okay. Let's move to number 3. A car starting from rest. What does that tell me? Who can tell me in chat, what does starting from rest mean? A car starting from rest. What does that mean? Very good. Kaylin, very good. The initial speed is 0. Accelerates in a straight line, at a constant rate of 3 meters per second squared. So it means my acceleration is 3 meters per second squared. You notice that I had to write these words out. And that's because in the, when I put the quiz online, it doesn't know how to handle the exponent. So if I had just put in 3.0 meters per second squared, it would have given me an error message. So whenever you see it written out, like I've done here, is to make sure that it will be acceptable in the in Blackboard when I make the exam or the quiz. How far will the car travel in 10 seconds? So my time is 10 seconds. And I'm looking for the distance. How far will it travel in 10 seconds? And I know it's along the x-axis, so normally I write this as what? As x. All right. My equation is very simple. X is V initial times time plus 1/2 acceleration times time squared. So that what I can do in my head. Look, I know what time is. Time is what? 10. 10 squared is 100. Okay, 100 times 3 is 300. Half of that is what? 50. You see, some of these problems, once you plug it in, once you write the equation, you don't even have to go and do the next step, because you can almost see a problem like this and you can solve it in your head, which I would encourage you to do if it's this simple in an exam. Once you see the part that you're going to solve and you're using your time wisely, you can just solve it. So that's one of the ones I want you to understand. And when you recognize it in the exam, solve it very quickly, or just in your calculator if there's some fractions there. But you see, in this quiz so far, I've given you very, very easy numbers to work with because I wanted you to do it quickly. Any questions? Okay, any questions before I move to number 4? Okay. So we just discussed that when an object moves from rest, that simply means that the object begins with initial speed of 0. So let's write that down. I'm going to work on number 4 now. Let me see if I can get it moved up. Okay, number 4. Okay. Okay, class, let's look at number 4. A car starts from rest. My initial speed is 0. Accelerates at a constant rate in a straight line. The constant rate simply means that whatever that rate is, it remains the same. In the first second, so my time now is 1 second. In the first second, the car moves a distance of 2 meters. So my distance is 2 meters. How fast will the car be moving at the end of the second second? So this question I chose because I want you to understand what is meant when the car is accelerating. So here, this marks my initial position. The car moves a distance of 2 meters in the first second. So that means then when it starts here and ends here, it's going to travel a second beginning with some other initial speed. In other words, during that second, the initial speed is not 0. But it still is going to travel for another 1 second. And it wants to know how far will it travel in that second. So in order for me to solve for this problem, how far it's going to go, I need to find out something about what happened in this first second. So one thing I can find out in this first second that could be useful is I can find out the acceleration. Okay. So who can tell me, just come off mute and tell me which one of your kinematic equations would you solve to find this acceleration and why? I'm listening.
Would you use x equals vi t plus half a t squared?
Okay, very, very good. Okay, now, if I knew the acceleration over here, and I could put it here, of course, if I found it, it would be constant. But what I still don't have is the initial speed. So I also need to know what is the initial speed, which means then I've got to find out how fast it's going after this traveled for this distance of 2 meters. So that means then I'm gonna put it down here. I know my initial speed was 0. I know my time is 1 second. It went a distance of 2 meters. But what I really want to know to put here is what was the final speed, which becomes my initial speed up here. Okay, someone come off mute and tell me which equation will I use to find my final speed. I'm waiting. Which equation would I use to find the final speed? In other words, if you look carefully right here, I don't have the acceleration in this part of the problem. So that means then I simply look for the equation, my kinematic equations, where I do not have to use acceleration. So again, come off mute and tell me which equation is that. No one can find it?
Is it x equals half vi plus vf times t?
Very good. Very good. Okay. So that means then, in order for me to find how fast will the car be moving at the end of the second, I've got to first of all find the initial velocity. I know the time. I know the acceleration. I can find my final speed because my final speed is always my initial speed plus AT. So I have to find A, which you can find here. I have to find V final, which becomes V initial in the second part of the problem. And then, of course, I can find what? V final, how fast the car will be moving. Oh, I'm supposed to have V final there. Hold on. Okay, I made an error. I'm looking for V final. I'm looking for a V final. Okay. So what is the car's, okay, go into chat. What is the car's acceleration? What is the car's final speed in the first part of the problem, which becomes the initial speed in the second part of the problem? The value for A is constant, so whatever it is here, it's also the same here. And then I can find the final speed. So I need to have two answers. Well, three answers. The acceleration, the final speed, which is the initial speed, and then the final speed at the end of the problem. So I'll look in chat and see who can answer that question. Just put A equals VF equals, well, in this case, VF equals, but you're going to use that VF over here is V initial, and then what does this VF equal? Okay, so I'm going to chat to see who can answer these questions. I'm going to ask Nigel to hold off and Kaylin to hold off to give others a chance to see if they can also answer. So I know that Kaylin and Nigel want to chime in. If you want to chime in, you can give it to me privately. Nigel and Kaylin, and also Keston's been answering some questions. So you three can give me the answer privately. And the others, I want to see what your answer is. I'm waiting. Acceleration, V final, and then V final in the second part of the problem. So far, I don't have any answers. Y'all can't solve that? Is everyone still there? Hello?
Can we all just do this one together? Like, solve it together?
Okay, we can do that. Let's go down to this. Can y'all see this part where my pencil is moving? Can y'all see that?
Yeah.
Okay, all right. So we said that we need to know the acceleration. So in this first part here, we do not know the final speed. So I think someone told us to use the equation that says that the displacement, which is my distance, is 1/2 V initial plus V final times time. So I'm looking for, oh no, I'm sorry. I'm looking for acceleration. Let me go to the other equation. X is V initial times time plus 1/2 AT squared. Okay, that's what I need to use because I'm looking for A. I know X because X is D, that's given. I know V initial, that's 0, that whole term is gone. So what I'm solving for now is this A when I know X and I know T. So let me show you again, because I was talking to someone earlier, and I want to show you again this algebra. My objective is to get this A by itself. So the first thing I do is multiply both sides by the reciprocal of this fraction because it's a fraction. And of course, the reciprocal of 1/2 is 2/1. Now, of course, 2/1 is just 2. So I say 2 here and 2 here. When these 2's cancel out, now my equation says 2x is AT squared. And of course, to get A by itself, that means I'm dividing both sides through by T squared. So when the T squares are gone, now I have an equation for A right here. And that A is simply 2 times X divided by T squared. But T is just 1. So that means my denominator is going to be 1. So 2 times X means 2 times 2 meters. So 2 times 2 meters, of course, is 4 meters. And T is 1. So 1 second times 1 second is 1 second squared. So now I have my acceleration 4/1, which is just 4 meters per second squared. Now, accelerates at a constant rate means that this acceleration, which is 4 meters per second squared, is the same over here. This is also 4. Okay, now I found that out. Now I need to know, once it has reached once it has accelerated at 4 meters per second square, now I want to know, what is the speed? In other words, how fast is it going before it begins its second of movement? So right here, I want to know, how fast is it going? So in order to find that, I've got to find this V final. And of course, now that I know A, I can just say that V final is V initial plus AT. Because now I know that V initial started out at 0. Now I know what A is. Okay. It was moving for 1 second. So now I know that at the end of this, okay, for 1 second, in fact, that's what this means. The speed is increasing 4 meters per second every second. And it's only been moving for 1 second. So therefore, it has sped up to 4 meters per second, A times T. Okay, so what is A? A is 4 meters per second squared. What is T? 1 second. What cancels? One of these seconds cancel one of these, because second squared means second times second. So therefore, I get 4 meters per second.
I have a question.
Okay, very good. Go ahead.
Okay, we have both of the times being 1 second. Why isn't the second one 2 seconds?
Well, the question says, how fast will the car be moving at the end of the second? So that means that this is my first second, this motion is my first second, and this motion represents my second, which is also 1 second. Okay, so the car starts from rest and it travels for 1 second. And now we know its speed after traveling for 1 second. So now we say, okay, after that first second, it's moving 4 meters per second. And the question is, how fast will the car be moving at the end of the second? The second 1 second, that's what it means. So how fast will it be moving here at the end of the second? So now it starts from here at 4 meters per second. It's accelerating 4 meters per second every second. So what's my final speed? So now I'm right here now. This gives me my initial speed is 4 meters per second. It's accelerating at 4 meters per second squared for how long? For 1 second. So when I cancel out this second with this second, I've got 4 meters per second plus 4 meters per second. So at the end of the second, it's moving at 8 meters per second. Okay. Now, let me show you something else about this problem. Okay, let me show you something else. Let me clear this. Can I clear this now? I know it's kind of jumbled on my paper, but hopefully you're writing yours down because you have more space than I have to write. Writing yours down clearly. Now, let me emphasize something here too. You notice that the problems that I give you on the quiz are directly from the assignment, or maybe it'll be from the homework. And all I'm doing is changing the values. I may change the problem slightly, but I want to make sure that you understand the very problems that we are doing. But unless you are doing the problems, So you have it to study, you're just not going to learn it. So I implore you, I tell you, you have to write it down, you have to review. Sometimes you may want to rewrite your notes to clearly understand what you have written in a more logical manner. Okay, so let's just see what we've covered here. What we said was this object is accelerating at 4 meters per second every second. That's what it means. So that means then, if it starts from rest, after it has been traveling for 1 second, it is moving at 4 meters per second. Then it travels another 1 second. But every second that it's moving, it increases its speed by 4 meters per second. That means after the second second, it is traveling 8 meters per second. Now, who can tell me how fast? Now, you see, in this case, I do not have to even go and find its speed, its final speed. I have to solve it now, because now I know that it's going to increase its speed by 4 meters per second every second. So that means that after it's been traveling for 3 seconds, quickly tell me, how fast is this car moving? Someone tell me very quickly.
12 meters per second.
Very good. It's moving at 12, because every second that it's moving, it is increasing its speed, means it's accelerating at a constant rate of 4 meters per second, and it's doing that every second. Now, when we go to our motion on the y-axis, it means the same thing. If I start here, my initial velocity is 0. After it has fallen for 1 second, 1 second later, the velocity is 9.8 meters per second. And it keeps falling. And it keeps getting faster at a rate of 9.8 meters per second every second. That's what that means. So I hope that cleared up for you how to solve this type problem. So that means then in the next exam, next quiz, or this problem, if you see it again, that means this. Once I find the acceleration, in this case, we said it was 4 meters per second squared. I don't really have to find the final speed to begin the new speed, because now I know what this means. This means that after the first second, I can find its speed. After the second second, I can find its speed, because every second it is increasing at a rate of 4 meters per second. So if I ask you, how far will the car be moving at the end of the, let's just say I say 4th second, at the end of the 4th second, you can solve it now, because now you see that it's increasing its speed, what? 4 meters per second every second. So the final speed after the 4th second, we got 4, 8, 12. Now we have what? 16 meters per second at the end of the what? The 4th second. So I pulled that problem out to use it in the quiz, because I wanted to explain to you what this means in every instance. Okay, very good. Any questions? Okay, number 5. A car is initially traveling at 36 kilometers per hour. Okay, so my speed is 36 kilometers per hour. Okay, the brakes are applied and the car stops. So that means that my final speed is 0 over a distance of 25 meters. So my distance it travels is 25 meters. And my question is, what was supposed to be the magnitude of the car's acceleration while it's braking? So I want to know what's the acceleration, and my units are so many meters per second squared. Because I could not put, again, this in Blackboard. So now the first thing you have to do is say, which equation am I going to use? And clearly, because time is not given, I choose the equation that says V final squared is V initial squared plus 2AX. V final squared is 0. Now in this problem, I again want to go over the algebra. So notice this. If I subtract minus V initial squared on the right side of the equation, that means that V initial squared minus V initial squared on the right side, that whole term is gone. That means in reality that what I have actually done is I have taken V initial squared, which is positive on the right side of my equality symbol. I've taken it across the equality symbol, and whenever any term crosses the equality symbol, its sign has to change. So rather than adding that, now I am subtracting that. That's what it means. So all I have left over here now is 2AX. Now again, to get the A by itself, I need to divide by the coefficients. In other words, the numbers that are being multiplied by A, I need to divide by those same numbers on the other side. So when I do that, it's the same as saying 2x on both sides. So that cancels out, that cancels out. Now I can solve for A. So I'm going to move up here so I can have more space. So A equals V final squared. V final is 0. So I have 0 minus V initial squared. Now, if you look very carefully, the first thing you see is that this V initial is in kilometers per hour. But my answer needs to be in meters per second squared. So before I put this number here for V initial squared, I need to convert that to its SI unit. But look at this. We already know that kilometer means 10 to the third. So we can say 3.6 times 10 to the third meters. And we already know that 1 hour is 3.6 times 10 to the third seconds. So since I know that, then my conversion is very simple. I've got, I'm sorry, I said 36. I'm sorry, it's 36. Take that out. Hold on. I said 36. Let me take this out. There we go. Okay. 36 was my speed, 36.0. So I got 36 kilometers. I replaced kilo with 10 to the third. And when I divide that by 3.6, then I get 10. So I have 10 meters per second to be squared. Now, I want to show you this. This negative number is still here because I don't have negative 10 meters per second to be squared because the negative is outside of my value. So this answer remains negative. And when I square that, of course, I get 100 meter square second square. And I divide that by 2x. So that's 2, and x was 25 meters. So I got 100, which is negative, divided by 50 meters. So of course, 100 divided by 50, we know that's 2. So my A is -2. One of these meters will cancel one of these. So I have meter per second square. Now, I wanted to show you this answer because what I asked you for was, what was the magnitude of the car's acceleration? Now, you know when you're driving and you take your car from a higher speed to a lower speed, you have to be applying your brakes. So what is the word that we use when we say the car is braking? Rather than saying acceleration, what do we say? Someone type that word in for me. I'm looking for the word that means that what happens when you are braking? You're getting slower. So what are you doing? I'm looking for that word. Okay, very good. Keston gave us the word. Kaylin gave us the word. Very good. Deceleration. So sometimes you have to read between the lines. So the question was, what was the magnitude of the car's acceleration while it was braking? So while it's braking, it is actually decelerating. It's getting slower. And in this case, it actually got slower. But the magnitude of it is just how much, like what is that number? So again, you see this word magnitude is an important word to know. It means what is the absolute value? And the absolute value, of course, for this number, remember you used to do this in high school, absolute value, is always what? It's always a positive number. Okay? So this car is decelerating at 2 meters per second every second. So now I'm going to go right here. I'm right here. Okay? The car is moving at 10 meters per second. What's happening is this. Every second is getting slower by 2 meters per second. Every second. That's what it means. So now someone tell me, this probably isn't on the notes here. I want to know, how long will it take the car to stop? How long will it take this car to stop? In other words, it's going from 10 meters per second down to 0. How long would that take? Type it in if you know the answer. How many seconds will it take this car to come to a stop? I'm waiting. No one knows? Nope. Someone else. Good try. I'm glad that you tried, Kaylin. That's good. Okay. I want you to try again. I'm thinking that some people are not even paying attention to this problem. I just went over this problem when I explained to you what it means to decelerate or accelerate. No one can get it? Lex, you can't get it? Keston, you can't get it? Monier? Lanisha, thank you. Very good. Okay, Lanisha, do you mind explaining to the class how you were able to do that problem? Can you visualize what this problem is saying, or did you have to solve it?
I just figured out. Honestly, I just guessed it by halving it.
Well, you don't have to guess it. Look what it's saying. It's saying that every second, the car slows down by 2 meters per second every second. So after 1 second, the car is going 8. Another second is going 6. Another second is going 4. Another second is going 2. And then after 5 seconds, it's going 0. That's what it means, class. It's saying that the car is slowing down at 2 meters per second every second. That's what 2 meters per second squared means. So initially, it was going 10. We said that the initial speed in SI units was 10. We got that 10 from converting. Down here, we converted that. We got 10 meters per second. So after 10 seconds, after moving for 5 seconds, okay, this was the first second, it went to 8, second second, third second, fourth second, 5 seconds. That's how you can do it. Now, if you want to do it, don't want to do it that way, you have to solve it. So let's go right here and solve it. What is the time? Okay, we said the time then is my unknown. But I know the acceleration, I know the final speed, I know the initial speed. And we said that, I know I'm running out of space, but I'm choosing it right here. My initial speed now is 10 meters per second. I don't know the time. I know my final speed is 0. And I know that it's accelerating it's slowing down. So this number is actually negative 4 meters per second squared. So which equation am I going to use? The one that says V final is V initial plus AT. I'm looking for T. So that means I have V final minus V initial over A. V final is 0. 0 minus V initial is 10 meters per second. A is negative. What is A? Negative, what was A? Oh, it's 2, I'm sorry. This is 2. This is 2, I'm sorry. Negative 2 meters per second squared. Okay, so negative over negative, of course, gives me positive. And we know that time has to always be positive. Time can never be negative. So 10 divided by 2 is 5. Meters per second divided by meters per second squared is seconds. Because this cancels this. In the denominator of the denominator moves to the numerator. So one of these cancel one of those. This is moved up, and my answer is in seconds. Okay. I hope that by reviewing this, that you will save these notes, because I'll put you on alert some of your questions for your first exam will come from these questions. I may throw in a couple of others of the easier ones. You see, I chose these questions because the concepts in these questions can be broken down to easier questions that you have to answer first. But these questions have multiple steps. So if you learn A, B, and C, you must learn A and B to do C. So therefore, I've also taught A and B. Now, speaking of an exam, initially I had said that we would have an exam at the conclusion of chapter 3. But since you all have shared that this material may be moving too fast, I want to go ahead and give an exam on chapter 1 and 2. So that exam will be next Monday. Next Monday, we have an exam on chapters 1 and 2. So go ahead and put in your notes when our first exam is. And that exam will cover the material that I will be reviewing on Thursday. So tomorrow, we will go over assignment 2. So please go ahead and look at that. I'm going to look at some of it now. We still have 15 minutes. And then I'm going to give you a quiz, just like we just finished doing here. I'm going to give you a quiz from the problems in assignment 2. Like we just did, I'll give you 5 of those problems. And of those 5 problems, they will come from the quiz. So let's move to that quiz. We have enough time for that now. We'll do some of that now. I'm saying quiz, but I'm trying to say assignment 2. So let me see if I can pull up assignment 2. Okay, so let me just clear this. So if I were you, I would take this page, of course, and I will save it. Now on tomorrow, I need to spend half the time going over the assignment 2. And the other half, I need to spend making sure that you understood chapter 1, especially on the problem for the components of a vector. In fact, I'm going to go over that again, hopefully tomorrow. Okay, let me find the assignment. Give me just a minute. Okay, can everybody hear me? Because it says my speaker is not working. Okay, great. All right. Okay, we're looking now at the chapter 2 assignment 2. So let's look at these problems number 14, 15, and 16. If I can do 14 and 15 and 16, we're going to do it together. Then you can do 11, 12, and 13 because they're very similar. Okay. Do you all see the writing on the screen? You see the writing on the screen? Just say yes or no. So anybody can just say yes or no.
Yes.
Okay, great. A tennis ball is shot vertically upward in an evacuated chamber inside a tower with an initial speed of 20 meters per second. So the initial speed upward is 20 meters per second. Now, that's all they told us. At t equals 0, when it first starts out, it has initial speed that pushes it up like this. And it says, how high does the ball rise? So in order to find how high the ball rises, that means that we know that at its maximum point, that is its final speed has to be 0 because it will rise until it reaches 0 and then it'll begin to fall. So therefore, we know that the final speed is 0. Then it says, how high will the ball rise? So I want to know what is y. How high will it rise? Now, again, remember from our strategy, we have to know 3 things. So there's a third number here that we have to know. So who can go in chat and tell me what that number is, what that value is that we know, because there's a reason why we know it. So I'm going to go here to chat and see who can tell me what do I know in this problem that's not does not appear to be given. We call it explicitly. It's implied. Who can tell me what that is? Gravity. Okay. So what about gravity? Okay, very good. The object is under the influence of gravity. What's gravity doing to it? What is gravity doing to this object? Someone tell me. In this picture, slowing it down. Okay. So that, now we just saw in our previous problem that in order for an object to slow it down, it has to be what? Deceleration. And therefore, we've already understood now that deceleration always means that that value is negative. And that's why I explained to you why the acceleration due to gravity is negative 9.8 meters per second square. And you can see why now, because it has an initial speed of 20 and something is slowing it down at 9.8 meters per second every second. So the question though is, how far will it travel as it's slowing down? That's my why. So again, we don't know how much time it took, but we do know that it goes to 0. So I have an equation that says V final squared is V initial squared plus 2AY. So we've solved this equation several times. So now we should know we're looking for y. This goes to the other side and it's negative. So v final squared minus v initial squared, it goes to the other side, that's why it's negative. And I divide it by what I'm multiplying y by, which is my coefficients of y. And that, of course, is 2a. So now I'm ready to plug in my values. V final is 0. So 0 minus V initial. V initial is 20. And 20 squared will give me 400 meter square second square. Okay. Divided by 2a. So 2 and a is negative 9.8 meters per second square. So now, how high does the ball rise? Well, negative divided by negative will give me a positive. So I've got 400 divided by 9.8. That's almost like 10, right? So 400 divided by 10, that would give me approximately what? I've got 400 divided by 10. It's approximately 40, right? But since it's a little less than 10, my answer is a little more than 40. So therefore, what answer are we going to choose for my value? And then of course, second square and second square cancels. And one of these meters cancel one of these meters. And negative over negative will give me a positive. Okay. So what is the exact answer that you got on that problem? Okay. Okay. Divide by 2. And you get, okay, Kaylin, thank you very much. We got 400 divided by 9.8. That gave us about 40 something. Divide that by 2. And we get what? 20.4 meters. Okay. Very good. All right. How high does the ball rise? It rises to 20.4 meters. Approximately, how long does it take the tennis ball to reach that? So now, given this, the same given here that we have, now we can solve for time. That didn't want to go away for some reason. Okay. Now, the same given, but instead of solving for y, I want to solve for t. So we have an equation that says V final equals V initial plus AT. Now I want to solve for t. So t, of course, is V final minus, this goes to the other side, V initial divided by A. So now we have 0 minus V initial was 20 meters per second. A is negative 9.8 meters per. Let me show you this. whenever you're about to write anything in the denominator of the denominator, actually that term moves to the numerator. That's what it really means. So when meters and meters cancel, this second will cancel one of these seconds. And therefore, I get my time in seconds. Also, negative divided by negative will give me a positive, and that's very important because time is never negative. Time is a scalar. So I have 20 divided by 9.8. This is almost like 10 again. So I got 20 over 10, which is about 2 something. So when I do that problem, I will get 2.04 seconds. Okay, so now determine the velocity of the ball at t equal 3 seconds. So they're saying at t equal 3 seconds, what's happened to the ball? Well, one thing you know for sure, you can see for sure that if it takes it 2 seconds, 2.04 seconds to go up, clearly after 3 seconds, it has to be doing what? Coming back down, right? But it says, what's the velocity? Well, the first thing you know is this. It took it 2.04 seconds to go to the top. So that means then my time is expended is 2.04 seconds, and it's at the top. Now, it's got to come back down. My total time is 3 seconds. It wants to know, what's this doing at 3 seconds? So it starts to fall, okay? VI is 0, starts to fall. But I've already spent 2.04 seconds going up. So 3 seconds later means that I've got to subtract 3 minus 2.04. That's where it is at 3 seconds later. And then I can find out how fast it's going in that amount of time. So what I say then is I have 3 seconds. Someone tell me how much time it has to go from 2.04 to 3 seconds coming back down. How much time does it have left to fall for 3 seconds? I got 3 minus 2.04. Quickly, tell me how much time I have. Okay, very good. I've got 0.96 seconds. So then, how fast is it going? My speed, we've already gone over this now. My speed is downward. So it's going to, that's why it's negative. My acceleration times my time. So once I find that time, I multiply that by 9.8. And that speed is downward. So then, how fast is it going? Quickly, someone give me the answer. Okay, very good. 9.4. Now, is it 9.4 upward or downward? Go ahead and put that answer in there, Kaylin. It's 9.4 what? It's 9.4 what direction? Downward. And we know that because when I solve for this, I've got negative 9.8 times positive 0.96, and that answer is going to be negative. And because it's negative, it must be moving what? Downward. Okay, we'll stop there. Please go ahead now. We're going to dismiss class, finish those other problems, and submit that to me. Let's see, I'll give you till noon tomorrow. Finish all these problems, do them slowly so that it won't take me much time to go over the ones that you don't understand. And that way we can move quickly to chapter 1 for our review. Okay, quickly. So sign out by signing your name. Okay, I'm not going to have time to type it because we're already over. Just I'm looking for your name as you sign out. Okay, everyone do that. Very good. Very good.
Did you already send this homework assignment?
I did.
Okay.
It should be. It's also on Blackboard.
Okay. Thank you.
Okay, and I've done several of them for you, so you shouldn't have any problem getting a good grade on this one. Okay, so Kaylin, Kendra, Nigel, Lex, Keston. Okay, y'all can go ahead and sign out. I haven't heard.
Dr. Edwards,
Yes, sir.
did you want the homework due today? Yeah,
Wednesday.
Wednesday.
Mhm.
Okay, Wednesday before class or Wednesday evening?
Just have it ready to discuss.
Okay,
I'm going to go over a few of those. I'm not going to spend as much time on those as I am the ones that I'm going to prepare you for the exam, because it's going to be, I've got to review what we have tomorrow and some of the homework problems, so I can have Thursday to go over the exam. I mean, preparation for the exam. Okay. All right. Lanisha and Monier, you all can sign out. I see that you're all here. Okay, very good. Yes, sign out yet? Yes. Did Yasmin, you sign your name yet? So you can sign out?